Isosceles and equilateral triangles. Base angle theorem. It gives the base angles. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. If side AC is congruent to side BC, then angle A is congruent to angle B. So whenever you have a triangle with two sides, they are congruent, which is isosceles. Their opposite angles right here, they are congruent also. So this is called base angles theorem. So proving the base angles theorem, we're going to look at this triangle. This one has angle 1 and angle 2. And then side XY is congruent to side XZ. And then this XB bisects this angle YXZ. When you bisect, that means this angle 1 and 2 are congruent. We gotta prove that this angle and this angle is congruent to each other also. So first, the given is side XY is congruent to side XZ. Please write this down. And then side XB bisects angle YXZ. Number 2, angle YXB right here is congruent to angle ZXB. And that is the definition of bisector. Side XB is congruent to side XB because these two triangles share right here. So that's reflexive. And then this angle, this triangle and this triangle shares side angle side. Therefore, the corresponding angles right here, after we prove that these two triangles are congruent, the corresponding, the leftover parts, they are congruent to each other, that is CPCTC. So this proves that angle Y and angle Z is congruent. Base angles theorem converse gives me the sides. If two angles of a triangle are congruent, then the sides of opposite those angles are congruent. So if angle A and angle B is congruent to each other, that means angle side AC and side AB and BC, side AC and side BC, they are congruent to each other. If a triangle is equilateral, then it's equiangular. So that means all these three sides are congruent to each other, then all these angles are congruent to each other. The converse of this is also true. If all the angles are congruent to each other, so angle XYZ is all congruent to each other, then side XY, YZ, ZX will be congruent to each other. So if you converse that, then that is also true. So we're going to go ahead and solve for X for each shape. This one we're solving for X. If this is X, and if this, see this mark, they are equal to each other, then this is X. So what we're going to do is write 54 is here. That means this is 54. Because this mark, this side and this side is congruent to each other. That means this angle and this angle is congruent to each other. So if this is 54, that's 54. If this is X, that's X. So 54 plus 54 plus x, this angle is x plus x, should equal 180 because that's the sum of a triangle. 54 plus 54 is 108. X plus x is 2x. Subtract 180 minus 108, 72. Divided by 2, x is 36. So x is 36. Let's take a look at this figure. So this mark, this side and this side is congruent. This side and this side is congruent. So if this is 50, 180 minus 50 is 130. If this side and this side is congruent to each other, that means this figure, this angle and this angles are congruent. So 180 minus 50 is 130. 130 divided by 2 is 65. So this is 65, that's going to be 65. So this is 50, 65, 65. So x is 65. Then how do I find y? If this is 65, then you can do 180 minus 65, which is 115. This is a linear pair. It's on the same straight line. So if this is 115, then you're going to subtract 180 minus 115 divided by 2, because this angle is congruent. If you do 180 minus 115, which is 65, divided by 2, then each side, y equals 32.5. So y is 32.5. We're going to solve for x and y for this figure. So you can see this mark, they are congruent. So if this is 50, that's going to be 50. Then that's 100, then that must be 80, right? Because together is 180. If this side is equal to this side, and then if these three angles are all same because of the marking, that means this is 60, this is 60, this is 60. This is a marking for equilateral. So I know this is 50, I know this is 60. What's this? That's 70 because all together is 180. 180 minus 50 minus 60 will be 70. If this is 70, that's 70 because this side is congruent. That means this angle is also congruent. So if this is 70, this is 70, then 180 minus 70 gives me the x. 180 minus 70 is 40. So x equals 40. Let's try this one. This one is, you have 50 here, and then you have these two sides the same, and you have a 90 inside, and you have n here. So if this is 90, this picture is not showing on the screen, but you have the picture on your notes. If this is 90, and you have a marking that's equal to each other, let me just pull up the correct picture. Hold on. So I got the picture. So right here, this is 90. This marking right here, that means this angle and this angle is also congruent. So 180 minus 90, which is 90, divided by 2. Then this is 45. This n is 45. This n is 45. So what we're going to do is n equals 45. And then you have a 50 here. So look at the bigger angles here. So what we're going to do is look at the bigger triangle. So 180 minus 50 is 130. That means this angle plus this angle is 130. But you see this marking? So this angle right here, this whole thing here, and this angle, they're going to be congruent. So what is 130 divided by 2? That is 65. So 65 minus this was 45. Then what is n? So you can find m that way. So m is 20. The answer is 20. Let's take a look at the next shape. We're going to find n and m. So this angle right here and this angle right here. So m is here. So what we're going to do is look at these markings. 1, 2, 3. That means it's equilateral. All three sides are equal. That means all three angles are equal. That must be 180 divided by 3, which is 60, 60, 60. So equilateral triangles always has 60, 60, 60. So if this is 60, you see this right angle? That's 90. So 90 minus 60 is 30. So n equals 30. If this is 30, this is 90, then what's this angle? So 30 plus 90, and then subtract from 180 will give me this one, which is 60. So this is 30 plus 90 plus 60, which is m, will give you 180. So we're going to look at the next thing. It says right triangle congruence. What tools do I currently have? Congruent triangle tools are side, 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 angle, side, angle, side, angle, side, angle, angle, side. Also congruent parts. After you prove if the remaining parts corresponding, that's C, P, C, T, C. So we're going to look at another tool, number 6. So we had another extra tool just for right triangles only. So please fill this out. Tool number 6 is called HL, hypotenuse leg. H stands for hypotenuse, which is the slanted side. Leg is the straight line here. So if we use this to prove two right triangles are congruent, if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another triangle, then we can say the triangle, these two triangles are congruent. So right here, you have a side, 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 angle, angle. So angle, side, side, angle, side, side can be used for only right triangles. So when they have a leg, congruent, hypotenuse, congruent, and the angle, right triangle 90, 90 congruent, you can conclude that these two are congruent right triangles. This is tool number 6. We call this hypotenuse leg. Usually, if we try to use this, we get a bad word because we have angle, side, side, angle, side, side. But we are working with the right triangle, so it is allowed to use it, but we don't use angle, side, side. We're going to use HL, hypotenuse leg, only for right triangles though. So key conditions for using hypotenuse leg, both triangles must be right triangles. The triangles have congruent hypotenuse. There is one pair of congruent legs. So these are the conditions. We use HL only for these, okay? Not any triangle. So here is an example. I want to prove that these two right triangles are congruent. They share a leg here. They share an angle. They have the same hypotenuse, which is the slanted across from 90. So let's write the proof. The given is angle PRS is an angle RPQ. You can write the given here. And you can say that this angle, all right triangle angles are congruent. This side is reflexive, therefore these two are congruent because hypotenuse leg. You have same hypotenuse, same leg. So you can actually write the proof, but the reason can be hypotenuse leg instead of side, angle, side, side. It only works like this for only right triangles, not just any triangle. So please write the proof. Thank you for watching the video.